Good morning. In this lecture video, I'm going to explain module 4. In that, first we'll discuss timers and counters, and then we'll discuss serial communication. So, yeah, 8051 timers and counters. Microcontroller application requires to count an events. That event can be an internal event such as a clock pulses. So we use as a timer. We can use this as a timer as well as counters. No? So to count the internal events such as clock pulses, we use as a timer. Also, timer is used to generate precise internal time delays between the actions. And to count external events, that is, for an example, number of persons entering or exiting. So we use it as a counters. And these tasks, that means counting the internal events or external events, can be done by a software technique, but keep the processor occupied. That and other most important functions cannot be done. So to overcome this burden, 8051 has two 16-bit up counters. Up counters in the sense it is counting up. Okay. They are timer 0, that means T0, and timer 1, T1. And timer 0 and timer 1 may be programmed to count internal clock pulses as a timer or programmed to count external clock pulses as a counter. That means timer 0 can be configured as a timer and timer 1 can be configured as a counter. Like that, individually we can program to count either internal events or external events, and both may be controlled, set, read, and configured individually. And timers have three general functions. They are calculating the time between the events, that means providing the delay, and counting the events. And the third one is generating baud rates for a serial communications. It is the most important to generate the baud rate. So these are the three important general functions of an 8051 timers. And the basic timer registers are both the timer 0 and timer 1 are 16-bit wide and up counter, but our 8051 is 8-bit. So each 16-bit register is accessed as a two separate 8-bit register. That means timer 0 is accessed as a timer 0 low byte TL0 and timer 0 high byte TH0, and similarly timer 1 as timer 1 low byte TL1, timer 1 high byte TH1, and these registers can be accessed by CPU like any other registers. The word timer is used when it is used to count the internal clock pulses, and counter is used when it is used to count the external pulses. So these are the registers. So this is the 16-bit registers. No? The lower 8 bits are that means D0 to D7 is named as TL0, and upper 8 bit, that is D8 to D15, is named as TH0. These are the two timer registers for timer 0. Similarly for timer 1, the lower 8 bits are TL1 and upper 8 bits are TH1. And let's see the special function registers involved in a timers. Timer SFRs. So SFRs related to timers are given below, and these can be accessed by using their names or addresses. So as you know, these are the registers of TL0, basic registers of TL0, timer 0, and these are the addresses: timer 0 I byte, timer 0 low byte, and 8Z 8A. Similarly, TH1, TL1, timer 1 I byte, timer 1 low byte, 8D 8B with the addresses. Apart from this, we need two more registers. They are timer control register TCON, and the address is 88. TMOD, timer mode register, 89. So TMOD is used to set the mode of operation, and TCON is used to control the operations. So we'll discuss this one by one. Yeah. Now first we'll discuss TMOD registers. timer mode register. It is an 8-bit register. It is an 8-bit register. This is the bit configurations. So it has 8-bit. Upper 4-bit is assigned for timer 1 and lower 4-bit is timer 0. The bits are gate, C bar, T bar, M1, M2. The same for timer 0. I mean used to control the mode of operation of both the timers. It's a byte addressable. It cannot be bit addressable. Upper 4 bits for timer 1 and lower 4 bits are assigned for timer 0. And now we'll see first one, gate bit. Gating control bit. So that means it decides how we can make the timer on or off. How we can make the timer on or off. So here, if it is 1, gate bit is 1, the timer bar counter is enabled. While INTX, here X is it can be 0 or 1. If it is 0 for timer 0, 1 for timer 1. INTX is equal to 1 and TRX is equal to 1. Again, TRX is a bit of Tcon register which we'll discuss next. So X is 0 for timer 0, 1 for timer 1. If both the bits are 1, then it is enabled when gating is equal to 1. So if it is 0, timer bar counter is enabled whenever TRX is 1. That means when gate is 1, timer enable is depends on two things. One is INTX and another one is TR. If it is 0, it depends on only TRX. If it is 1, enabled. If it is 0, disabled. So that means for every timer we need a start for stop control. We need start for stop control, and some timers do this by software, means we can make on or off by software, and some by hardware, and some timers have both software and hardware control. Our 8051 microcontroller have both software and hardware control. That means TR, I mean timer run control bit. So they are tier 0 and tier 1 controls start or stop by software using an instruction set bit tier 1 or clear tier 1. That means tier 1 is equal to 1 or 0. That means timer 1 is on or off. Similarly for timer 0, set bit tier 0 makes 1, so timer on. Clear tier 0 makes 0, tier is equal to 0, uh, timer 0 off. It's not 1, timer 0 off. And this is achieved as long as gate is equal to 0. And the pin INTX, that means INT 0 and INT 1 controls start or stop by hardware. That means so we connect one hardware circuit, for an example simple switch. If the switch is on, timer is on. If the switch is off, timer is off, like that. So if INT 1 bar pin is 1, timer on is on. If it is 0, timer on is off. Similarly, INT 0 is 1, timer 0 on and timer 0 off. Okay, it is achieved as long as gate is equal to 1. Gate is equal to 1 as and TRX is 0. And next two bits, M1, M0. M1, M0. So they are called mode select bits. They are called mode select bit. These bits are used to select the modes. So we have different modes, the 4 different modes. They are first when both are 0 0, mode 0, that is 13-bit timer bar counter. If it is 0 1, then the mode is 1, it is 16-bit timer bar counter. And if it is 1 0, mode 2, that is 8-bit auto reload. And if it is 1 1, mode 3, that's a split timer mode. Split timer mode means in this only timer 0 is used. In that TL0 is used as a timer bar counter and they are controlled by timer 0 bits. And TH0 is used as only timer, 8-bit timer, and it is controlled by timer 1 bits. And timer 1 is itself is stopped. That is why we call it as a split timer mode. Okay. And the next bit C bar, T bar, counter bar, timer control bit. So this bit is used to select either timer or counter. Suppose when it is 1, when it is 1, counter mode is selected. That means counts external events or pulses. When it is 0, it selects timer mode, counts internal events, and that can be used as a delay generator, and timer will increment for every machine cycle. And if it is 0, crystal frequency attached to 8051 is the source of clock for the timer. And if it is this means crystal frequency attached to 8051 decides the speed of timer. Frequency for timer is always 1/12 of the frequency of the crystal. That means crystal frequency divided by 12, then that is applied to the timer. Okay. So in the next video we discuss T-con register. Thank you.